I'll be taking you on the concept of heat. We said before now that physics is divided into 4 parts. We have heat, we have the concept of magnets, we have electricity, okay, and we have that of optics. We are taking optics already together with wind. So what is heat? Heat is a form of energy due to temperature difference. You cannot discuss heat without talking about temperature. It is a measure of the total internal energy of a body. That is what heat is all about. Heat is measured in joules. Evidently, it's an energy. If energy is measured in joules, that means heat is also in what? It's measured in joules. And you know what temperature is? Even the children will tell you that is what? That's what? So, I leave that for you to answer. So, temperature is the degree of hotness or coldness of the body of a place. And then heat is dependent on temperature. Just like I've said, by the time we are dealing with this concept today, definitely we'll be making mention of temperature at every point in time. So, and temperature, the instrument for measuring that is thermometer. So we have various types of thermometer, which is liquid in glass, very common. A good example is the alcohol and the mercury. You must know their distinct differences while using them, and then the similarity and so on. So which one do we prefer to the other and why? Those questions will always flow from there. So the next one is gas thermometer. It uses gas. This one uses liquid. That's why we are taking alcohol and mercury as our case study. And then the resistance thermometer uses resistance. So now, the next thing you must be careful about is your temperature scale. Question will always flow from here. We have 3 scales of temperature. One is the Celsius scale. We have the Fahrenheit scale. We have the Kelvin scale. And in taking note of these scales, you must know the upper fixed point and the lower fixed point. Because if I want to give you a question relating to the scales, I will make mention, for example, of Celsius. Then you must take note of the 0 and 100. That is the lower fixed point and the upper fixed point. If I'm expecting you to compare whatsoever I'm giving you to Kelvin scale, you must know that the what? The lower fixed point is 273 and the upper fixed point is 373. That of Fahrenheit scale is 32 as the lower fixed point, then 212 as the upper fixed point. This must be right here. So let's move to the next concept. We're going to solve questions on this later. Now, we have the concept of expansivity on the board. When there is heat, there's going to be an expansion. And again, once heat is out, what happens? There's going to be what? Contraction. That's why if we want to go in depth, we can use the concept of bar and gauge experiment, for example, or ball and ring experiment. What is ball and ring experiment? You have ball and you have ring. The ball will always go through. But on hitting the ball, bringing the ball into the ring, you find out that the ball cannot go through again. What do you think is happening? Because there is heat, expansion occurred, and then it cannot go through the what? The ring. So 3 things happen. It's either there is expansion through the length, or length and breadth, or the 3, which is length, breadth, and height. So on one way, we call it what? Linear expansivity. That is through the length. Through length and breadth, we refer to it as area expansivity. If you don't call it area expansivity, you can refer to it as superficial expansivity. And the third one is cubic expansivity, which is also known as, okay, that's the third one, the cubic expansivity. Alright? Linear expansivity, area expansivity, cubic or volume expansivity. Now take note, twice the linear expansivity will give us area expansivity. That's under that note. It's very significant. Because I can give you a question on linear expansivity, then I will give you area expansivity. Question can flow from volume expansivity and you'll be given the linear expansivity. So what do you do at that point in time? Find 3 times of that linear expansivity and it will give you the volume expansivity. And with small analysis from the first and the second, that means 1.5 area expansivity will give you that of volume expansivity. These formulas on the board very valid. Please let's take note of the first one. Linear expansivity is change in length all over the original length multiplied by the change in the difference in the temperature. That's change in temperature. Area expansivity is change in area, that's A2 minus A1, all over the original area multiplied by change in temperature. And the last one is the volume expansivity, which says change in volume all over original volume multiplied by the change in temperature. Definitely, if you know one, you've known the rest. Substitute L and put A there, then it becomes area, expansivity. For L, put V, then you have volume expansivity. So take note of the formula on the board. We're going to make use of it as we move on. Let's move to the next part. So thermal expansivity. What is thermal expansivity? It is the tendency of matter to change in shape, area, and volume in response to a change in temperature. The temperature will determine what will happen. So, through heat transfer. There is one concept you must know, that in heat, heat will always flow. In the concept of heat will always flow from where? Hot body to what? To cold body. That's why you are not expected to often open your what? Your refrigerator down. Why? Because the environment is hotter than the refrigerator. Therefore, heat will always flow into it, and you give the compressor more work to do. So, and a room that is having an AC, the same thing happens. You don't open the door anyhow. Why? Because there's going to be what? Infiltration of heat into the environment. And then we move to the next point. Let's look at this point. Let's note this one. Relationship among linear, area, and volume expansivities, effect and application, all these I'm giving you here are required in your JAMB exam. We're going to look at the relationship among the linear, area, and volume expansivities. You talk about the effect and application of these expansivities, and then you are going to determine volume, apparent and real expansivity of liquids. And you should always be able to explain the concept of anomalous expansion of water. This question is always repeating itself. Before we move into the next slide, anomalous expansion of water happens between 4 to 0 degrees Celsius. You know what happens there? When water drops down in temperature, something is expected to be happening to the water. But when it gets to 4 degrees Celsius, it changes the behavior. We'll talk about that when we are solving problems. But take note that it happens between 4 degrees Celsius to 0 degrees Celsius. Now, note, let's look at this. This can be a question, but I am taking it as a point of note in this class. Pressure lowers the freezing point of any liquid. It's a form of fact. Once there is pressure, then the freezing point will be what? Will be lowered. That's of liquid. Okay? Which expands on solidifying. There are some liquid that expand when they solidify. That's why you find out that the container at times will what? Give way. Because there is expansion while it was solidifying. Okay? There are things you don't put into your refrigerator once they are in a particular container. Because there is going to be expansion, and that thing will burst at the end of the day. So, impurities lowers the melting point of any pure solid. Once there is impurity, then the melting point is going to be reduced. You can see those questions flowing from different angles while you are writing your exam. Number 2, impurities in liquid raises the boiling point of the liquid. Once there is impurity, you rest assured that the boiling point of that liquid will definitely what? Raise up. Now let's look at point 3. It says, increase in pressure at the surface of a liquid will raise the boiling point of the liquid. I repeat again, increase in pressure at the surface, take note, of a liquid raises the boiling point of the liquid. And vice versa. That means we can say now that what? Decrease in pressure at the surface of liquid, what will now happen? It will reduce the boiling point of the liquid. So the question can come either way. Take note of the 4 points that is up here. Now, quantity of heat. Like I said, heat will always be transmitted or transferred from what? Hotter body to what? To cooler body. Now, the quantity of heat, what does it depend on? It depends on the mass. Because if I have two bodies, one small and the other one very big, the quantity of heat that will be transmitted or transferred to the smaller one at a particular time is going to be different from that of the one that is very big. So it depends on the mass, and then it depends on a constant called specific heat capacity, and that's represented with small letter c, MC, and then definitely there will change in what? In temperature. Maybe the body was formerly 10 degrees Celsius. Upon receiving heat, it becomes 50 degrees Celsius. The difference in the heat content now is that temperature is 50 minus what? 10. And that will give me 40. From 40 to 50. The difference is going to be what? 40. So note, the MC you have there is known as heat capacity. Not specific again. The C alone is specific, but once we multiply it, because it's a unit mass. But with the mass, the whole mass taken together, it is known as what? Heat capacity. So, don't forget, heat can always flow from electricity at the same time. Assuming you are using your boiling ring, you want to heat your water, there is going to be heat flowing through the what? The wires. Into the what? The coil, and then to the water. And then it's giving us what? IVT. It's no longer MC the theta again. It's IVT. I stands for the current that is flowing. V is the what? The voltage, measured in volt. Current is in ampere, definitely. And then your T, which is the time taken for the flow of the current. So we have IVT. And the IV there is the power. That's what is noted here. We have to be very careful about that, because the question can supply you with the power. Then you are busy looking for the current and the voltage. Where is the power? The voltage not giving, current not giving. Then, forgetting that you are giving power. IV stands for power, and it's measured in watts, definitely. So if you can multiply the power by the time, you have gotten the what? The heat supplied by the electricity. Let me give a good example. Okay, before then, let's take the assumption. Assumption here says no heat must be lost to the surrounding. That's the ambient. What do we mean by that? There's a practical that is guided by this. So we are not taking that here. We are only applying what we have from this formula. No heat must be lost. That means, for example, if I have a hot body and I'm transmitting that hot body into a cool body, let's take, for example, you have a container carrying water, then you have hot metal, and you transfer the hot metal into the what? The container. Definitely the heat from the metal will be transmitted into the what? Into the water. We are assuming that there is no heat loss to the surrounding. What does that tell you? That means the total heat that the body, the hot metal is having, will be transmitted into the what? Into the water. At the end of the day, we can now assume that what? Since there is no heat loss to the surrounding, therefore, heat lost by the what? By the hot body must be equal to the what? Heat gain by the what? The cold body or the cooler body, as the case may be. So that's where the assumption comes to play. You're going to see questions flowing from there. The information about the hot metal given, the information about the water that you have in the container given, then heat flows from the hot metal into the water. So in the case of latent heat, that's the last line. What is latent heat? It's a scenario whereby there is change of state, but there is no change in temperature. Have you ever wondered? You bring water from your refrigerator or freezer, as the case may be. You looked at it and it's looking as if it's blocked in nature, but upon coming out, you notice that it turns to water all of a sudden. That is, there is that heat that it sensed, and then it turns it. It has not gone into the solidification process for long. So that's heat, that heat that cannot be quantified by that change in temperature is referred to as the latent heat. Okay, so we'll be coming back very soon to take up on the other issues concerning heat. Thank you, sir.